All right, this is the second lesson for quantitative data. We had talked about dot plots and describing the shape of data. We'll get into a little bit more of that in this video, but we're really only looking, there's two big pieces to this video. We're talking about stem and leaf plots and histograms. Those are the next two. So we did dot plot, we said there's four main types. Dot plot, stem and leaf plot, which I said was going to be in the last video, but that ended up being pretty long. And then we have histograms, and box and whiskers, which will come up in the next section as well. But we're just going to focus on stem and leaf plot and histograms in this video. So I'd like you to go ahead, I'm going to pause this video. I need you to write down this in your notes, so draw a line and put stem and leaf plot. And then we have this example here, shoes owned by 20 female AP stat students. So I want you to go ahead and copy down this chart for me. All right, I'm going to give you a few moments to do that. All right, so now that we've got things going again, we got this written down. Now what we're going to do is we're going to write down some steps for how to make a stem and leaf plot. This is probably my least favorite type because it requires the most amount of work, but it is going to be important for AP exam and then understanding its composition for those that are in dual credit. You have to know how to read one of these, so constructing one is going to help us really the most with really fully understanding what it is. So I have to apologize in advance. There are a lot of rules that we're going to write down, a lot of steps. So I'm going to go ahead and show those to you. And we'll go through these one piece at a time, but I'll go ahead and pause the video with the screenshot of this so you can write these down. All right, let's go ahead and get started. So the first thing we want to do, and in your notes, you're going to, next to your table, well, down below you can do this. So we have our example. We're going to start, oops, I still have that from the last video. Let me make that solid. We'll go black line. All right, so we're going to start with this. Over to the left, we have our stems, and over here are going to be the leaves. So the first thing it says is separate each observation into a stem, all but the final digit, and a leaf, the final digit. It says write all possible stems from the smallest to largest in a vertical column and draw a vertical line to the right of the column. So we've kind of already done those two steps, except we are now going to describe what we mean by stem. So the first part says all but the final digit. So what is the final digit in our graph here? Well, the 9, the 7, the 1. Those are really the tens place, or excuse me, the ones place on these numbers. So we're going to leave those alone, and we're only interested in the tens place. So we have something in the 19s, the 20s, the 30s, there's a 49, there's a 50. So those are all the different places we have. So we're going to list those out. So I'm going to start with 1. That represents the 10s, then the 20s, the 30s, the 40s, and the 50s. That's how we get our stems. Now, if there had been like an 8 and a 3, I would have to redo this, and I would have to have a stem that starts at 0. You always want these to be from smallest to largest. So I'm going to put that smallest to largest. Always. Always, always. All right, so that's the first part. Erase that. Okay. That's the first part. Now, we want to go to the next. Write each leaf in the row to the right of its stem. Arrange the leaves in increasing order out from the stem. So here's the stem, 1. So I'm looking at all the numbers that have a 1 in the tens place. That's this 13 here, 13, 13, 15, 19. So all of those are going to be placed in the leaves column. And again, we want to go from smallest, it said increasing order, to largest. So we're going to start. What is the smallest number? Well, it's these 13s. How many are there? Well, there's 3 of them. So 1, 2, 3. And I'm going to go ahead and check that I've used those, so you can do that in your notes as well. Then I have 15 and 19, so 5 and 9. Got that? I should put check marks on there. Okay, we got it. Now we start the next row. That's what we're doing. So I'm going to identify all the 20s. So 26, 26, 23, 24, 22, 23. That's all of them. we start with the lowest. Which one's the lowest? Well, it's the 22, so I'm going to put a 2. By the way, you want the numbers to be the same size and you want them to line up, okay? So we got 22, 23, we have 2 of those. So 3, 3. I'm really trying not to mess up, because if I miss one, that's going to be a problem. I have to go back and erase everything. So you want to take your time with this. The next one is 4. Got it. Then we have 2 6s, so 6 and 6. Got it, got it. All right, that's the process. Let's keep it going. Let's do the 30s. Here's 31, 34, 30, 38. There they are. So let's start with the 30. I'll put a 0. Got it. 31. Got it. 34. Got it. And then 38. Got it. And I didn't miss anything. Next, the 40s. Here's 49. Put the 9 in. There's no other there. So 50, 50, 57, and 51. So we'll go ahead and get those, starting with the 50s. 0, 0, 2 50s, 51, and 57. There we go. Now we're done. That is a stem and leaf plot. That's all you have to do. We're going to describe this with socks. All right. So I'm going to ask you questions like we did in the last video. What is the shape of this distribution? Well, you might be thinking, well, how in the world am I supposed to look at the shape of this? So what you'd want to do to find the shape, let me show you an example, is you're going to, I think I can use paint to do this. All right, can I flip this, rotate? Yeah. So you're looking at it like you would a dot plot. So we have these dot plots right here. Here's our dot plot. You know, notice how there we have the number line, and then we're looking at our distribution. Here the number line is on the left. So what we want to do is we want to rotate it. So I'll rotate it this way. That's how we're really looking at this. The lowest values over here, the highest values over here. So you kind of want to do that in your mind. So on a test, obviously you're not able to do this, but on a test you want to take it and flip it. It's upright, so you want to flip it this way so you can read it. So how would you describe that shape there? Symmetric, skewed left, skewed right. So shape. If you said skewed to the right, as long as you argue it correctly, your explanation would be there are fewer values on the right than there are to the left. There are a lot more small values than there are the large amounts in the 50s. So you could say skewed to the right. If you said symmetric because the pattern's kind of close together, that's fine as well, but as long as you know how to explain it, okay? If it were free response, you'd want to write out sentences. You're not just going to get away with saying skewed left, skewed right, or symmetric. You need to actually write a sentence for why, okay? What about outliers? Okay, and I'm not going to ask a question about that, but let's just talk about it. So if you said that 9 is an outlier, or 49 is what that would be, that would not be correct, okay? Because it is in the pattern, okay? It is in the pattern. And you know what I realized? We forgot to actually do the last step from creating this. Let's go back and do that. Provide a key that explains what the stems and leaves represent. So let's make sure we have that. Whoops, sorry about that. So we're going to put key. Sorry to jump around. Let's pick a number. I'm going to pick the 5 and the 1. So if I say 5, 1, this means I'm looking here at 5 and going to the 1. This is represents a female AP Stat student with 51 pairs of shoes. All right, so this 9 would not be an outlier in this situation. To get back on track, it does fall in that distribution and in the pattern. So I would not say that there is an outlier, okay? Center, where's the center? Where's that balancing point for this? Again, if we look at it this way, Where is that balancing point? So you might say between 2 and 3, or you have to, maybe you feel like you have to pick one of those, but you'll notice it's a little bit more difficult to actually pick an exact value for this. So if you said stem 2 seems to be where the center is, or stem 3, that would be sort of how you want to explain that. You can't really just pick like 26 or 24, okay? Not like you can with a number line. So we could say stem 2 or stem 3. Spread, well, that's 57 minus 13, so 44, okay? That's all we're gonna say for now, okay? All right, so we got that. Now, this shape overall, all the numbers are really close together. So we have another way of drawing a stem and leaf plot that we're gonna be doing. All right, so we're gonna keep our data over here handy, and you can write this lower in your notes if you want. But we have what's called a split stem plot. Oftentimes splitting the stems is a good idea. If you have a lot of data, you definitely want to split the stems, because if I had a ton of students on here, these columns would just fill and fill and fill and fill. Like obviously the majority of them are going to be up here, but you could get so much data that you know, you can't really tell the shape. So sometimes we want to split the stems, meaning we are going to create, man, writing on this thing has been kind of rough today. Create multiple domains for each stem. That's what we want to do. Example, 0 to 4, 5 to 9. So instead of this representing all the numbers for the tens place, like all the tens numbers and the teens and such, we are going to separate them into two groups. So let's go ahead and draw again in your notes the stem and leaf plot. So we're going to put stem, leaves. I'm going to write each number twice. There we go. Now, each row represents these values. So it'd be 0 to 4. So that over. That's 0 to 4. This one's 5 to 9. And then it just keeps alternating. 0 to 4. 5 to 9. And this is just that ones place. So if I go back to my data over here, in this top row, all that would be in there are 3 3s, because they're the only ones. They're between 10 and 14 is what that means. Now we want between 15 and 19. So I have a 5 and a 9. Then I go to 2. All the values between 0 and 4. So I have a 2, 3, 3, 4. And then for the next one, it's 6 and 6. And this pattern just keeps doing that. It's going to alternate. So now I go to the 30s. I get 0, 1, 4. And then an 8. And then we go to the 40s. This one's blank now. There is nothing in this spot here. So I'm going to get rid of that. Oh, crud. So we're going to go ahead and put the 9 in here, right here. So we skip a space. Then we're going to put 0, 0, 1, and then 7. Again, what's the benefit of doing this? Well, now we can really see the shape a little bit better. Over here on our original one, it was really tough to see because there weren't enough stems. And that's the real problem. Like, it's harder to see the shape if you don't have enough stems. So that's the benefit. Now, we could also do this with 0 to 1, 2 to 3, 3 to 4, 4 to 5, 5 to 6, or sorry, hold on, 0 to 1, 2 to 3, 4 to 5. We could do stems like that as well to really spread it out. And this is all based on, do you have a lot of data? Now, if we do socks again, you'll notice you could still argue that it's skewed to the right, maybe even symmetric if you wanted to, but you can tell the shape is definitely, it looks different when you display it like this. Outliers, you might be able to argue a little bit better that this is an outlier because it's really kind of far away from what's normal. Okay, most of the data is over here. The center, now we could say probably 26 is more of an accurate one, or accurate value. All right, and then the spread, of course, is still the same. All right. All right, so next we are going to look at one more type of stem and leaf plot, and I know I'm 16 minutes in here, but we want to, the reason I'm going over this is you need all of this examples for your homework. I want to look at this graphic here. We want to make what's called a back-to-back stem and leaf plot. So we have our data here. I'm going to copy a couple things into this. So we're going to add males to this. So males and female data, shoe data. And let me go back and grab, I want to get my original stem plot. Actually, I want this one, this new one here. Let me snip that real quick. There we go. Let's throw that into right here. Perfect. Let's paste this. All right. So this was our females. This is our split stem plot. Now we want to create what's called a back to back stem plot. And this is our equivalent to this graph here. How we're going to be comparing two distributions. So it's equivalent to these two dot plots that we compared. And what we're going to do is we're going to create two lines. In between here are where the stems go. So we're going to put stems. And then this one will represent female. These leaves. And this is male. And I'm going to go ahead and put we're basically going to copy the females in here. So go ahead and draw that with me. And let's just go ahead and copy the females in because we already know how that looks. If we had not, we would just, if we had to create one brand new, you would do it the exact same way that you did when we were making it. Okay, so there's the females. Now, we're going to do the same thing for the males, but you'll notice that I've already made an issue here. Because if we look at the males, look at all these digits. These are single digit values right here. All of those. There's so many of them. And I missed one. There they are. So I actually, and you're going to have to do this too, need to erase. And I need to add one more section up here. If I can get it to work. So you're gonna have to extend yours. You can't just put it at the end. It doesn't work like that. They have to go in here. And I'm gonna draw my line, and this is gonna be female, and this is male. And this is so important here with this detail because you'll notice that the females don't have anybody in the tens or in the single digits, but the males do. So we start with the lowest. This time we're working our way out. This is the smallest, this is the largest. Okay. So we start lowest number is 4. So I'm going to put that 4 right here. Now remember, this is 0 to 4, and then 5 to 9. So that's the only one that's going to go in there. Now we go to the 5s. So there's 1 there, so 5. How many are there? There's 1, 2, 3, 3 5s. 2, 3, so we check those. How many 6s? There's just 1, so 6. Then we have 1, 2, 3, 4 7s, so we're going to keep writing numbers 7, 7, 7, 7. Check all those off. All right, and then an 8. So you can see here, this is the largest stack here. We're trying to make the numbers as even as possible. We don't want to write any numbers bigger than others, but that may have happened here for me. Let's go ahead and get rid of that. Now we're into the 10s. This is 0 to 14. So 10, 10, 10, 10, 11, 12, 14. All of those numbers are going to have to go in here. So how many 10s? 1, 2, 3, 4 of those. So 4 zeros, 2, 3, 4. Then there's an 11. So I'm going to put a 1 in here. Then there's a 12. And then this 14. So I got all those. All right, and then the next highest digit is actually 22. So we're gonna skip that one and go straight to this one. I'm just gonna put a 2 right here. All right, then there's 35 and 38. So 35 and 38. 35 is gonna go in this second column, or second stem for the 30s, and then 38 will also go with it. And there we go, we've got it, a back-to-back stem and leaf plot. This is how you'll see some of these on the test. I know one of the test questions is going to say what would be an appropriate stem to use. By the way, if these were in like the hundreds here, I would put a 0 in front. Okay, and then if I got here, this would represent 157. So you're going to add the digits, sort of like we did with the random digits table in the book, where we had to have multiple numbers that we'd go at a time. Okay, so that's it for the stem and leaf plots. Last type, and this will finish off this video. So we have a histogram. So for a histogram, these are sort of just going to be what we say about the steps. This is just another way to represent quantitative data. And really the biggest thing is to note a few things. So first off, these are going to be our steps for making it. So on the calculator, first you want to create a dot plot. So you have the steps for that. I don't have to go through them. So go ahead and go to the dot plot of drive time. So this was the data sheet. Pull that back up. Don't save anything if you have a file, but get this dot plot up right here. So I'll give you a moment to do that. I'll pause it even. So get the dot plot of the drive time to SCHS. So minutes drive to SCHS. All right, so that's the first step. Next, change the dot plot to a histogram. From the menu. All right, so we go here, pull up the calculator, you press menu, plot type, there it is. There is your histogram and it's created for you, okay? So here you can hover over it and it shows you, you'll see these numbers. That is your that's the bar width. So you'll notice that these bars, it looks like they are 3 wide, so 15, 16, 17, but it's not including the 17. You'll notice the bracket versus the parentheses. So this is actually how many values are between 15 and 16. So we have 10 people that have a 15, to 16-minute drive. Okay, that is our most in that category. All right, so that's what we're seeing here. We're going to adjust a few things on this because even though this calculator has made a bar graph that looks good, we want to adjust a few things. And the reason we're going over that is because I want you to make sure you have this right for the test. So first off, we want to adjust the width we'll call that the say width of the bar, or as we'll call it, the class. Okay, so each one of those are classes, and if the number falls in that class, we add a point to that frequency, okay, of the histogram. So this is how we do it. So we're going to say picking, put a little star there, picking the correct class widths. This is important for the test. So first off, you need the number of classes. How many bars should exist? That's really what we're trying to say. How many classes exist? We're going to say the number of classes is equal to square root of n. Okay, square root of n. Well, n we've talked about briefly. N is the sample size. N is the sample size. Well, what is our sample size? Let's go over here. If we can't tell from this, we go back here and we're just counting how many students are there. So Elijah, Hannah, Madison, we can go all the way down and we see that 35 students have filled this in. Okay, so going back to our example, and we'll write example in here. N equals 35, so we take the square root of that. What is the square root of 35? And we need to write down our rule here. We're going to say rounded. All right, we're rounding that. So let me pull up my calculator that I have here. It's just a little quicker. So we're going to square root, 35 square root 5.9. So we're going to round that up. So 5.9 approximately 6. So that's the number of classes that we should have to make a really good bar graph. Here, they have a ton. Okay, they're using a different formula to get their class width. But this is the way that that AP and dual credit will want this. Okay, next, class width equals max minus min over number of classes. All right, so we need to go get that for our example, from our example. If I just peek over these, we know it's between it's 1 or 2, and then this is 29 or 30. But just to be really sure, we need to go look through it. There's a 30, that's the highest possibly. And here's the 2. So Morgan is 2, Hannah's 30. Okay, so 2 and 30, I think, are the highest and lowest. Seems good. So we're going to write that in. Let me go back here. So we have 30 minus 2 over how many classes? Well, 6. So that's 28 divided by 6, which doesn't divide evenly. But we'll just double check. We'll just go ahead and use our calculator to do this. 28 divided by 6. So 4.6 repeating. Here's the rule for this. We're going to, let me double check my notes really quick. Let me pause. So we're going to round to the next whole number. We're not rounding down. So we're going to say round to the next whole number. So that's what we needed to do. Round to the next whole number. So what that means for us when we got 4.6 repeating, even if this had been 4.1, we would still round up to 5. So we're going to round up to 5. We have 5 widths. Okay. Or our class width is 5. So 6 classes, the width is 5. So let's go to our calculator. And I'll write down the steps for this. So this is menu, plot properties, histogram properties, and I believe that it is bin settings. Menu, plot properties, histogram properties. Bin settings is what we want. And we're going to click equal bin width. So let me go back and do that. So histogram properties, bin settings. There's a lot of steps to this. And this is equal width. Variable width means we just have varying widths across the whole thing. So equal width. So we're going to put the width of what we just got, 5. Alignment, that's fine. Go ahead and hit OK. There we go. So we have 15 points. So our scale is not fitting that. Let me zoom. If you click zoom data, it will now show it. And this is what you'd want to graph. Okay, even though it's not as detailed as the other one, like if we do that, go back, it's not as like detailed as that. It's still a more appropriate graph for the way that that AP and dual credit wants it. So this is actually better. There's one more thing that we need to do, and then this video is going to be over. We want to, so for change the y-axis to relative frequency. And if you remember what relative frequency means, we're talking about percents. All right, so this is the last thing we're doing. So we go, to do this, to follow these steps, menu, plot properties, histogram properties, the scale is what we want, and you can see we want percent. So that's much better. So it shows the actual percents of each bar, which is going to be super handy. So 42% of people, that's almost the majority, are from 11 to 15 minutes of commute time. That's information that we want. A lot of times counts are not very reliable, and we would rather have percents of this quantitative data. That's what makes histograms so nice, is we can see how many fall between certain ranges. Histograms are going to be probably the most used graph in this class. They're just probably the best to use. Dot plots are too simple sometimes, and a histogram can tell us quite a bit more. Okay, so we're gonna go ahead and end the video there. You now have, you're able to do all the homework that's assigned, the first 2 sheets this week. I think we're gonna do 3 this week. So make sure that you get those knocked out, and go ahead and stop it there.